In this slidecast, we'll discuss merge sort. Now, a merge is a common data processing operation performed on two sequences of data with the following characteristics. Both of the sequences are ordered by the same comparison operator. And the result of the merge is a third sequence that contains all the data from the first two sequences. So here's a merge algorithm. We access the first item from both sequences, and while we're not finished with either sequence, we compare the current items from the two sequences, and we copy the smaller item to the output and access the next item from the input sequence whose item was copied. And then when one of the sequences is finished, we copy the remaining items from the first sequence to the output, and we copy any remaining items from the second sequence to the output. So here we have sequence A and B that are merged to perform an output sequence that's in sorted order. For two input sequences containing n elements, each element needs to move from its input sequence to the output. So the merge time is order n. And the space requirements are that the array cannot be merged in place, so we need some additional space, order n space. Here's the code for a merge. And we have a left and a right and a left and a right end iterators, and we have an output iterator. And here's the basic idea is we find the smaller value and we insert it into the output sequence. And then we copy whatever's left over. Now, merge sort, we can modify merging to sort a single unsorted array. If we split the array into two halves, we sort each half and then merge them. And we can do this algorithm recursively. So here's a recursive algorithm for a merge sort. We say if the table has more than one element, we store the first half of the table in left table and the second half in right table, and then we recursively apply the merge sort algorithm to the left table as well as the right. And then we call the merge function with these two tables as input sequences, and then the original table as the output sequence. So here's a picture to trace how this merge sort works, using recursion to split an unsorted array into two. So we'll start out by taking the left half and the right halves and placing them in their own subarrays. And then we'll recursively call again to put half of the values in their own subarrays. And finally, we'll do that until we can split the halves into their own subarray, and then we'll copy them back in sorted order. We'll do the same thing with the right subarray. In this case, we need to switch the 30 and the 45. So now each of these arrays are sorted, and we'll just merge them. So we'll merge them to the higher level. And now here we'll take the right subarray, divide it into two, and we'll continue that until we get a small subarray of size 1, and then we'll merge the results. So 80 and 15, we'll switch them. Once we have the sorted subarrays, we can merge them. And then finally, in the last step, we'll merge the two halves to get a final sorted array. So conceptually, that's how the merge sort works. So each backward step requires a movement of n elements from the smaller size arrays to the larger ones, so the effort is order n. And the number of steps which require merging is log n, because we always split the array into two at each step. So the effort to reconstruct the sorted array through merging is order n log n. Okay, n times log n steps. Now going down through the recursion chain and sorting the left tables, a sequence of right tables of size n over 2 and then n over 4 is allocated. Now this series is a total of n additional storage locations are required. So here's the code for our merge sort. And here's where we calculate the middle value so that we'll create a left and right table. Here's where here's the recursive call on the each half of the table, and then here's the merge operation on each of the sorted subtables. And that brings us to the end of this slidecast.